Jackson and Rex. The topic is adopting Compose and KMM, the journey to multi-platform app development. A bit about both of them. So Jackson is a dedicated engineer and technical lead with over 12 years of experience in mobile application development. He possesses extensive expertise in Android, iOS, web, and backend technologies, having successfully led and contributed to over more than 30 projects across the various domains. If we talk about Rex, he is also a skilled engineer and associate technical lead with over 6 years of experience in mobile application development. He has proficiently worked with Android, Flutter, Kotlin, multi-platform mobile (KMM), contributing to a variety of successful projects. So, without any further ado, let's welcome Jackson and Rex. Over to you.
Hi guys. So myself Joseph Rex and
Yeah, I'm Jackson.
we both are actually Android product engineers. We are actually working in Entry. Talking about Entry, we are a vernacular learning platform. We actually provide educational contents in seven. Is it audible now? Is it fine now? Yeah. Is it fine now? What about now? Yeah. Yeah. Okay. Okay. Fine. Yeah. So yeah, we actually provide educational contents in 7 different regional languages in India. So our current texts we currently using are one Android app and one web app. And the key features we currently have is video streaming, interactive live video classes, voice discussions, and AI-driven some functionalities. And our future vision is to have a multi-platform mobile applications. So about our goal, like this multi-platform app development, actually we set our goal to an iOS app. We currently didn't have an iOS app, so that's what we set our goal to. So for that, we actually have to cover some milestones, right? So we figured out some milestones, and one of them is Compose, which is a declarative UI, and second one is KMM. So these are the milestones we actually choose to reach our goal, to reach our iOS app with any multi-platform mobile application development stacks. So let's start with our first milestone, which is Compose. Why we choose Compose? Actually, obviously, Google was investing too much heavily in Compose. Like Apple invested on Swift UI, and obviously there is the sweetness of declarative UI is already there, and XML. Actually, XML is the language which we used in Android to write UIs. So if we are going on with it, we have to switch in between two languages like XML and Kotlin. And also, if we are considering a screen which lists some contents, if we are going with Kotlin and XML, we have to write 200 of codes. If we are switching it to Compose, we only have to write 50 or 60 lines of code, which means almost 60 or 70% of code reduction and easiness. And also, when we think about when we have to adopt Compose, the Compose was already when stable, so we didn't have to think much about that. We just started working on it. Yeah, like the challenges we faced while we worked with the Compose is that at the initial stages we faced a lot of recomposition issues. Recomposition issues means like at the end this UIs are all drawing in the screens, right? So at the initial time, if we didn't at the initial time we didn't have followed properly this best practice in Compose. So that time there happened so many rendering time issues. There happened so many recomposition issues at the initial times. And also, at the initial stage of Compose stable version, there is already so many exceptions which is happening, but we didn't get the exact reasons of what exact the exceptions are. We will just get that there happened some exception in some particular areas. And also, we already have an Android app with a bigger code base, like which already have like a lot of Android native views. So we have to use this Compose views inside this Android views. So by handling this life cycles of both this Android native views and Compose views was bit overhead. Like we literally have to manage the life cycles of both dependently. So that was one of the headaches we have. So then we actually kind of learned to adopt some of best practice, like separating this UI components and using a lot of mappers and all to separate this UI layer. And also just mentioning some few issues which we faced from the library side. As Android guys, we are dependent on material libraries a lot. So like see if we are using a text input layout which we placed inside any scroll views or something, if we started typing on it, the keyboard might overlay on this text input layout. And also if you are considering Android natives bottom sheet and Compose bottom sheet, there is so many issues like nested scrolling will not work if we use the bottom sheet in Compose. And like there are so many focus issues, like if you click on this bottom sheets and all, there happen so many focus related issues. That focus might be going to the background screens or something. These are some challenges which we faced at the initial stage. And for resolving these issues, we actually upgraded our some of our libraries. The first one was Kotlin. We initially were using 1.7 of Kotlin. We actually updated it to 1.8. But this Kotlin update actually itself takes a lot of time for us actually. It wasn't complex because as we have a lot of legacy codes, we actually have a lot of overheads, like we use so many plugins like Android synthetic extensions which we actually use to access the XML views inside our Kotlin classes. So 80% of our code base actually have this plugin. So removing all these plugins to update our Kotlin version was time taking, not complex, but it's actually time taking. Actually, our all Android engineers dedicatedly worked on it for 1 week. And we have to remove all the exhaustive end statements from our project. And like for better compiling, uh, we actually migrated from CAP to KSP also. And for better build time, we actually updated our AGP and Gradle. Yeah, that's these sections actually pretty much covered our first milestone, which is Compose. And let's move on to our second milestone, which is KMM.
Hello. Hello. Yeah. So the next step was after completing our compose, we moved on to KMM. So why we adopt KMM? So how many of you heard about KMM? Yeah. We are a kind of we have a strong Kotlin team. So when we trying to adopt a new language, so it will take time, right? So we have to hire new people, and we have to learn that, and we have to use that multiple language in a complex project. That will took time, right? So that's why we that's the one thing we chose Kotlin. And one more thing is like, how many Flutter fanboys here? Yeah. So no offense. Recently there is some layoffs happening in Google and all. So we don't know the future of Flutter. So that's one thing. The famous Jake Button. He's a guy in Android. He also said RIP Flutter. And yeah, but from that, another cross-platform technology is React Native. So when we maintain a React Native project in a large code base, it's kind of a tedious task because um, updating the dependencies and all will took time. If a new API layer comes up, API update is come to Android, and we have to adopt, and there is tons of dependency updates we have to do. So it's kind of complex. So that's the another reason we are not looking for Flutter and React Native. And our team members have solid experience on these platforms as well, and they are not they are also not recommending that. So after that, yeah, so we also have a solid app, and we have lots of business logics in that. If we can reuse that business logics, that would be good. So we can reuse the existing UI and business logic. So if we going for KMM, we can entirely reuse that, and saving cost to the company, because we are not hiring too many people. We can reuse our current team, and in terms of risk, we are not getting into a new technology, because we have already experience in Kotlin, and in terms of we don't have to maintain a new technology stack. For that also, it's a great advantage for KMM. Yeah, when and where to adopt KMM. So we started through the side projects, and everyone in our team has the side project, and everyone worked on it, and the side projects went well, and all the projects are worked in Android, iOS, and web also. And our team went confident on KMM, and we have a higher level management meeting, and they also reviewed, and in that meeting also they are pretty confident on that. And at that time, the so much popularity is coming, and there is much support is coming from the developer community, and yeah, we just have the confidence to going for the KMM. And yeah, then where we can implement this. So we pick a small feature, and its business logic side, and we implemented on that part. And it's basically the database layer and API layer, and we implemented that, and pushed to production, and everything works well in our Android app, and there is no problem at all. Yeah, for the integration of this KMM, we have some configurations and integrations, which are, we of course upgraded the Kotlin and AGP versions, and we have this database layer, and in that we used room database for early, and to use the KMM in KMM database layer, we have to use SQL Delight, which is a library by Square, and we have to use this shared preference migration in the KMM module as well. And we used Ktor for networking layer, and for the dependency injection framework, we used Coin. Yeah. So after the successful integration of KMM, we went for because in KMM we only took the existing business logic side. So we can move on to UI as well, right? So at that time we are introducing a new feature called Elevate. It's a skilling vertical, new skilling vertical in our app, and it offers campus placement and all. So our vision was to integrate business logic and UI into this section, because this entire module is kind of new, and every architecture is new. So we decided that we can go for KMM and Compose multiplatform. This Compose multiplatform is like a forked version of Compose, which is integrated by JetBrains, and we already have this Compose UI layer, and we transitioned this Compose UI layer into multi-platform module, and we use these components for UI and view model. For view models, there is a library called KMM view model from Rick Clefas. We used that also. This is an open source library. Yeah, after that we implemented that wall feature was implemented using Compose multi-platform and KMM. These are the small challenges, not small, yeah. These are the challenges we faced in Compose multi-platform adoption, because yeah, we have some legacy code base and all, and in that the data classes and API layer tied up, there is some coupling as well. So migrating this into a KMM module took time. Yeah. Yeah, another challenges is like lack of documentation, because as you guys all know, the open source open source, uh, because some library developers develop the library, but they lack documentations, because we have to go to their repo and raise a issue and find out what of the issue and like that. So we have some issues over there also. In ID and tooling issues, we have while we trying out KMM, it was in beta stage. So at that time, we have some issues in ID and tooling side also. So this guy called John O'Reilly, his repo and his blogs were have phenomenal support for us. And at that time also, we have to use multiple icons, whatever the drawables for our Android app. So we have to adopt to that into a multi-platform. We have to use this new multi-platform resource library, which of course kind of a breaking library. We have to move all the drawables into a multi-platform module as well. That was another challenge. Yeah, these are the small workarounds and hacks we did for uh, uh, KMM and Compose, because as I earlier said, there is some tied up with data classes and database layer. So we cannot simply migrate this into a KMM module. It took time. So for the release, we have to it is kind of time, we have to release this thing in a timely manner. So for the point for the hack, we used multiple view models in single activity, and handling SQLite exception. We also had this SQLite lock exception, because we used two instances of SQLite in our app, which is one is in room and another one in SQDelite. So we had this SQLite lock exception. So we have to manage that with a synchronized mutex via the Kotlin. There is a mutex in Kotlin. So using that, we solved. And after all this, we successfully integrated this KMM and Compose multi-platform. Yeah, next we will be moving to our iOS part of our journey.
Yeah, so after completing our second milestone, we actually jumped into our final step, which was our iOS app. So, thinking about why we started working on iOS app, actually, we in our web app we actually have seen a rising of iOS user base. So we actually have to provide them native experience for sure. And also, Compose multi-platform went to beta that time, and Google actually officially announced support to KMM and all. And also, a lot of library supports also increased that time. So, like we had a question like when we are going to start. So that time internally in our company there comes a hackathon program, which actually we named it as a game project. So each team, like Android backend, like front end, each team independently worked on their own problems. That time Jackson actually himself chose iOS as a production iOS app as our like goal. So yeah, we started working on it. We actually prioritized like a first level app which actually covers 30 or 40 percentage of our current existing Android app. So yeah, we started working on it. For that, we actually upgraded our like machines. We like integrated. We actually like get set it up with iOS development tools and stuffs. Like and like we planned to work on it in off working hours, like not in the working hours. We actually took it as a challenge because we actually on our research we actually believe that we can do it easily, because we already at that time we already have a declarative UI which completely goes with Kotlin, and we have shared business logics which we already which is already in shared module, and shared UI logics with the Kotlin multi-platform. It's already in shared module. The shared module means like if we are considering a KMM project, it's the project's folder structure is like there will be an iOS folder, there will be an Android folder, and there will be a common folder. This common folder contains the shared stuffs, shared codes, which we can use both in iOS and Android app. So in that section, we already had business logics while we completing our first milestone, second milestone, and we got this UI logics shared in the shared module using Compose multi-platform, and we have APIs using KTOR library, and we can access database in the shared section using SQL Delete library, and we have KMM view models which actually we can directly inject to used in our composables, and compose navigation, which is another key thing which we used in our iOS development. The thing is that while we working on iOS, our team didn't actually have an iOS developer with us. But even if we are going with KMM, we actually need to know some of the basics of iOS actually. I mean Swift and Swift UI. So, but it was pretty much sure that uh, we can go in depth to the Swift or Swift UI. So what saved us is that Compose multi-platforms navigation. Actually, navigation is a wrapper which can actually contains a lot of other UI components. Which means based on the inputs we providing to the navigation will switch the screen which we have to render in the UI. So what we did is that we actually in iOS app we actually used iOS navigation, which actually contains multiple UI components, and one among that child components we used Compose multi-platforms navigation. So, and we have a bunch of composables, which means uh, multi-platform UI components we already have, and we rendered uh, all these composables or this shareable components in this Compose multi-platforms navigation, and so that we actually, as I mentioned, we already had 50% of this thing done in the shared module. So all these things we only had to render inside this Compose navigation, which is the child navigation view, and in the parent navigation we actually used to render the native iOS screens. So that which pretty much actually solved our all these issues. When the iOS app starts, it actually renders the parent iOS navigation, inside which we have Compose multi-platforms navigation, which renders all the composables we have. So the challenges among in the iOS development was, as I mentioned, the Swift and Swift UI learning curves, and we actually were new to iOS project setup like permission declarations and all. Those things seems a bit new to us, and obviously we seek the help of our iOS developer friends actually, uh, but all those needs has been solved with just like few hours of calls and all solve those issues. And like the one among the overhead which we faced is that iOS's back handling, which actually in Android there is which was very easy, but in iOS which was bit tough for us. So we actually had to make some changes in designs. Our design team actually helped for that. So that's pretty much actually helped us to reach to our iOS app, and the key takeaways were at the end we actually found ourselves build an iOS app without an iOS developer. For that we actually had 20% of the things done with Compose, which means the Compose contributed us 20% of it, and 20% of it is contributed from KMM, and for sure we all are Kotlin guys. So by knowing one language, we actually covered 80-90% of our iOS project. And like one takeaway is that if we keep updated our libraries, if we take the hurdles we have to achieve that, the things will be done. Like it will be easy to cover all these things. And obviously, we saved the cost of hiring new iOS guys in our team. And at the end, we actually like turned to like uh, from an Android engineer to a cross-platform mobile application developer. And like yeah, and like all this feel like as I mentioned, we are Kotlin guys, and we literally feels home even if we build a stack, which means iOS, which we are not familiar with. Yeah, that is pretty much it. Let me show a small demo of our app. Yeah, it's the login section. Six four six. Yeah, this is our home screen, which we already done in KMM. And this entire logics and UI is actually currently shared with the Android app as well. And let me show a quick video section. And this section is actually also done in KMM. Like, this is completely done in KMM actually. But most of the things we actually done before we started working on like iOS. These screens actually we done in the phase of our KMM implementation itself. And this is a video screen. And this video player is actually completely written in like native iOS, in which we have to use DRM. We are using actually HLS as DRM. So this screen we have to use like I go for iOS native, and remaining all these stuffs we actually done in like KMM. Yeah, that's pretty much it about our demo. Any questions?
Yeah. Hello. So, how different is your Android and iOS code base? And like, do you when there's a new feature, do you test them separately? And is it a monorepo?
Actually, our iOS app is currently actually 40% of our Android app, and the codes we are using in iOS section is completely reusable in Android, which means actually 30% of our Android projects code is actually shared with iOS, and that 30% of our Android apps code is actually almost 80% of iOS app. So that much actually shared.
So most of it is shared, and just this little bits, maybe config and all, which is
No, actually, UIs as well as business logics are mostly shared, and the screen which I showed, like that video screen, that's the only thing which we have written in native iOS. The remaining stuffs are all actually I think 16 or 17 screens we actually completely done in KMM.
okay. So it can be like a monorepo. You don't need two repos. to
No,
make
no,
it.
no. We actually using a repo.
Okay, thank you.
Single repo.